Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good evening. I'm Azizul Ahmad. Today I would like to present the topic recent progress in the development of photovoltaic modular mismatch mitigation techniques. As an outline for the presentation, first about introduction, the second literature review, the third one methodology, and the fourth is result and discussion. As an introduction, solar energy is one of the sources of renewable energy that does not produce any environmental pollution. The photovoltaic PV device will play a critical role in supplying world energy for energy demand. Owing to different fault occurrence, both internal and external in the system, PV systems suffer from a large amount of power loss. Faults are caused by the variety of factors, and these faults must be identified and removed as soon as possible if the faults are not eliminated throughout the system. The fault analysis is essential to increase reliability, extract maximum power, and ensure the safety of the system. Mismatch condition. Variation of PV production, impure material, again of PV unit, and soldering are defined causes of internal mismatch. This could reduce the output power by approximately 10%, which is identified as a permanent issue in PV unit. On the other hand, mismatching causes such as shedding, power converter, and diode bypassing power losses are identified as external in PV unit. In our daily life, we can notice that shedding is a frequent phenomenon. Mismatch mitigation technique. In this proceeding paper, we just focusing only on 4 differences mismatch mitigation technique. They have been published recently. They are: first is bypass diode technique, second is bipolar junction transistor BJT based bypass technique, third one is series MOSFET bypass technique or metal oxide semiconductor field effect transistor. And the last one, we will discuss about current limiter mitigation technique. So we go the first one, bypass diode technique. This connection of bypass diode in a PV unit is made in parallel to minimize the impact of mismatch by restraining the reverse voltage. As aforementioned, the parallel connection is made across each as a sub-modular. These diodes are mainly proposed to protect the shadow cell from any temperature risk. The second one, BJT-based bypass technique. The BJT voltage drop at the saturation region is usually quite low. Therefore, it improves the total output power through a reduction in the bypass power losses. The effectiveness of the technique is that it made use of generate reverse voltage during shading condition to provide bypassing. Therefore, this technique contributes to extending the lifetime of submodular, which in turn extend the lifetime of the PV unit. The third one is series MOSFET bypass technique, which is having produced will lead to the decrement in the shared PV cell temperature, which in turn make of submodular and the entire PV unit more variable. The vital rule of this technique is that it minimizes the hotspot temperature and lessen the loss of power during shaded. And we have the fourth is current limiter mitigation technique. This integration of this circuit is not only providing a suitable solution to mitigate the problem of hotspot, but also eliminating the increase of the PV cell temperature during partial shaded scenario. Argue that the widely used current limited circuit as a limitation in which there is a large voltage drop in the operation of current limited, hence the PV modular voltage at the output of the limited would be affected and less power would be produced. This methodology, as we have the literature review, we try to clarification of mismatch condition and mitigation technique. Then we try to identify project objective. After that, we select of mismatching condition to mitigate. Then we select of mitigation technique, which one is the better, and we try to simulation the PV mitigation technique by using MATLAB, then performing maximum power point tracking or MPPT algorithm, then try to validate, simulate result and discuss finding. As a result and discussion, bypass diode technique produce maximum power point equal to 102 volt. By using BJT based bypass technique produce maximum power point is 60.74 watt. By using MOSFET bypass technique produce maximum power point is 80.25 watt. By using current limited mitigation technique result, it show better than other technique by producing maximum power point up to 112.4 watt. So this configuration are show that using current limited mitigation technique provide output power increment of 9.25% as compared to the bypass diode technique, or 46% as compared to BJT based bypass technique, and 28.6% compared to MOSFET bypass technique. So as a conclusion, a brief discussion of mismatch mitigation technique for PV unit was presented. Several category of mismatch effect which could be practically occur. Various passive and active techniques have also been overviewed. It is seen that the current limited technique can be considered as an effective technique to reduce the hotspot effect and improve the PV output power. So as an acknowledgement, I would like to thank Universiti Malaysia Pahang for providing financial support under postgraduate research grant scheme as well as for laboratory facilities. That's all for our presentation. Thank you. So we go to the Q&A section.